Hello everyone, welcome back to AP Physics C Mechanics, Practice FRQ Set 6, number 3. A 4 kilogram object is attached to a vertical rod by 2 strings as shown right. Here's the object, here's the rod, here's the 2 strings. And the object rotates in a horizontal circle with a constant speed, constant velocity of 6 meters per second. Part A, draw the force body diagram of all the forces acting on the object. Here's a grammar mistake. Whatever, it doesn't matter. Okay, so all the forces acting on a ball. First, there's Fg, force of gravity. And then there's T1 and T2, the two tensions. So now let's draw the components of each tension. This string is pulling the ball this way. And there's an X and Y component. X component will be here. This will be Tx1 and Y component Ty1. Okay, for tension 2, the same thing, pulling this way, Tx2 and Ty2. Okay, that should be all the forces. Part B and Part C, find the tension in the upper and lower string. Okay, we'll split this up into an X and Y component section. So, for the X component, the ball is spinning in a horizontal circle, which means there is a centripetal force F of C pointing from the ball to the center of the circle, which is where the rod is. So, and F of C will be equal to Tx1 plus Tx2 because these two forces are also pointing towards the center, the vertical rod. So, Tx1 plus Tx2 equals F of C. Okay. But what is Tx1 and what is Tx2? Okay. So, let's draw this at the bottom here. Okay. So, here's a rod, and here are the 2 strings. This is 3 meters, this is 2 meters, and this is 2 meters. Now, what you can do to find the angle to allow you to find Tx and Ty, you'll set a theta here and theta here. These two are equal because this is an isosceles triangle. So what you can do here is split this triangle right in half, so you create a 90-degree angle. Both sides of here will be 1.5 meters and 1.5 meters. Now let's take one of these triangles, pull it out, 1.5, 2 meters, theta, there. So now we can use trigonometry. Cosine of theta equals adjacent 1.5 over hypotenuse 2. Isolate for theta. Theta equals inverse cosine of 0.75, and we end up getting 41.41 degrees for the theta. Now, both Tx's will be right here, so Tx1 will be equal to sine T1 sine of 41.41, T2 as well. So Tx1 equals T1 sine of 41.41 plus T2 sine of 41.41 equals, this looks really bad, okay, equals Fc. Fc, centripetal force, equals mass times centripetal acceleration, which is equal to v squared over r. Now, what is r? R is this part, the radius of the circle. And we can find that by finding this mysterious angle right there. And to do that, we simply need to use the Pythagorean theorem, or like before, trigonometry. So 1.5 squared plus r squared equals 2 squared. I'll be using Pythagorean this time. Isolate for r squared equals 1.75, and r will equal 1.32 meters. Okay, we'll plug that into here. So, sine of 41.41 is 0.66 plus 0.66 T2 equals, mass is 4, v is constantly 6 squared over 1.32. Okay. 0.66 T1 plus 0.66 T2. We combine this all together and we get 165. Oh no, 109.09. And when we divide 0.66 on both sides, we get T1 plus T2 equals 165.29. Okay. Now for the y direction, there are three forces acting on a y direction. T1y pointing up, and FG and TY2 pointing down. So we'll set those two equal to each other. So TY1 equals FG plus TY2. So TY1 is T1 cosine 41.41 equals FG is MG plus cosine 41.41 of T2. Okay, cosine 41.41 is 0.5. So you get 0.5 T1 equals MG. M is 4 and G is 9.8. So that will equal 39.2 plus 0.75 T2. Okay, so we have two unknown variables, T1 and T2, and two equations. So what we can do is use substitution. We will isolate for T1 here. T1 equals 165.29 minus T2, and we can plug that right into here. 165.29 minus T2 equals 39.2 plus 0.75 T2. Okay, very messy, but you get the point. Okay, multiply this together, we will get 123.97 minus 0.75 T2 equals 2 plus 0.75 T2. Next we isolate for T2, moving this to this side and 39.2 to the other side. Subtract 123.37 by 39.2, we get 84.77 equals 0.75 plus 0.75 is 1.5 T2. Divide by 1.5 and we get T2 equals 56.51 newtons. Plug that in. And to find T1, we just plug this right in here. T1 equals 165.29 minus 56.51. And we get T1 equals 108.78 newtons. Okay. That was parts B and C. Now part D. Calculate the angular velocity of the object. Okay. Switch this around. Part D. So to calculate the angular velocity of the object, we can go back to T1, the FC. T1x plus T2x equals FC, which is mv squared over r. But this time, off to the side here, mv squared over r, v equals r, radius, times omega, angular velocity. So we will just put that here, m r omega squared over r. Okay? And this would equal to m, distribute the squares, mr squared omega squared over r. We can cross it out, crosses out. And we end up with mr omega squared. Okay. Well, T1x and T2x, as we found out, are 0.66 T1 plus 0.66 T2 equals our new mr omega squared. Okay. So next we'll divide 0.66 on both sides equals, okay, we'll plug this in. M is 4, R is 1.32, and omega we're trying to find. Divide by 0.66. Okay, we can plug in T1 and T2. It's 108.78 plus 56.51 equals 5.28. Okay, omega squared. Is that right? No, it's not. Okay, you know what? We don't need to multiply 0.6 to the other side. Okay, we'll just factor out 0.66. And we get 108, 178 plus 56.51 equals 4 times 1.32 times omega squared. Okay, multiply all this together, we get 109.09 equals 5.28 omega squared. Okay, 20.66 equals omega squared, and omega will equal 4.55 rads per second. Okay, sorry for the mishap, but whatever. Part E. Part E is how much time would it take for the object to complete 10 revs, 10 revolutions around. Okay. So we can solve that by using delta theta, or omega equals delta theta over delta t. Okay. We isolate for t. T equals delta omega divided by delta theta over omega. So we're going around the circle 10 times. A circle is 2 pi radians, and we're going 10 times. Divide by 4.55 rads per second. And this will give us 13.82 seconds. Okay, part F, final part. Calculate the frequency of the object. So frequency equals 1 over t. T being the period or the amount of time it takes to complete one revolution. So since this is this is 10 revolutions at a constant velocity. So to find one revolution, we just divide this 13.2 by 10 and we get 1.38 around there. So frequency will be equal 1 over 1.38, which will give us 0.72 hertz. And that is it. All F parts. I'll see you in the next problem, question 4.